Hello everyone. Today we shall begin the subject Geotechnical Engineering, and as per AKTU syllabus we shall start Unit 1. So first we shall talk about the soil. What is soil? Soil is defined as uncemented aggregates of mineral grains and decayed organic matter with liquid and gas in the empty spaces between the solid particles. You see, the two things are there: uncemented aggregate of mineral grains and decayed organic matters. These will be in the form of a solid particles, and in between the voids of these solid particles, either air may be there, gases may be there, or water may be there, or liquid may be there. What do you mean by soil mechanics? It is a branch of science that deals with the study of physical properties of soil and the behavior of soil masses subjected to various types of forces. Actually, this is a very important definition. You see, the two important points are there. One is the physical properties of soil, and another is the how the behavior of soil mass is going to be influenced, is going to change due to the application of various loads, various forces. As you know, whenever we are going to construct any structure on the soil or below the soil, what is going to happen? We have the behavior of the soils, which is available below the base of the footing, is going to change due to the application of vertical forces or horizontal forces acting on the structure, right? So what I'm trying to say here, we have to test the physical properties of the soil, which is available below the base of the footing, so that we could know the bearing capacity of soil. Without knowing bearing capacity of soil, we should not design the foundation, right? So these two things are physical properties and the various types of forces subjected to the soil mass should be studied. What is geotechnical engineering? It is the sub-discipline of civil engineering that involves natural materials found close to the surface of the earth. As you know, geotechnical engineering, geo is the earth, geo means earth. So what it says that the materials or the natural materials which is available nearby the surface, right, close to the surface, close to the ground surface, and it includes application of principle of soil mechanics and the rock mechanics to the design of foundations, retaining a structure and earth structure. See, application of principle of soil mechanics. Whenever we talk about the application of principle of soil mechanics, that means we have to remember the definition of soil mechanics. That means the physical properties of soil and the behavior of soil mass, which is going to be influenced, which is going to be changed due to the application of various types of forces. So that 2 points comes under the application of principle of soil mechanics. So that two parameters, physical properties, as well as the what type of forces is going to work on the structure, whether it is a vertical force or whether a horizontal force, we have to cover those all the points in the design of foundation or the retaining a structure or the earth structure. What is soil engineering? Here you can see the same thing, application of principles of soil mechanics to the practical problems. See, if the bearing capacity of soil is not adequate, or if you are not going to design the foundation depending upon the bearing capacity of soil, the problem will arise below the base of the footing. So what we have to do, we have to study the application of principle of soil mechanics. That means the physical properties of soil and the behavior of soil mass due to the application of various forces, which may be due to the construction of a structure, which may be due to the vertical loads, maybe the horizontal forces acting on the structure. So this we have to know, the application of principle of soil mechanics. Now we see the next topic is the preview of geotechnical field problems in civil engineering. This is the first topic of the geotechnical engineering subject in unit 1. So see, preview of geotechnical field problems. What does it mean? Preview. That means we should know what type of geotechnical field problems will arise if you are not going to carry out a study about the physical properties of the soil before construction of any structures, or what are the various forces going to work on the soil. And you see here in civil engineering, whenever you talk about civil engineering, so all these structures will come here, which may be foundation, which may be retaining a structure, which may be conduits. So what I'm trying to say here, the preview of geotechnical field problems that we have to know. So let us proceed one by one. Suppose we are going to construct the foundation. In that case, what is going to happen? We shall discuss one by one. First, we shall know about some introductory part of the foundation. Foundation of all civil engineering structures like building, bridge, highway, tunnel, canal, or dam is founded in or on the surface of the earth. You know that the highway or even the canal or dam may be constructed on the ground surface, whereas the building, bridges, or tunnel below the ground surface. So on the ground surface, canal or dam we can construct, or below the earth we can construct the building or bridges like that. And foundation is termed shallow foundation when it transmits the load to the upper strata of the earth. Normally literature says, and we have to know also, the shallow foundations we construct only up to the 3 meter, approximately 3 meter below the ground surface. A foundation is called deep foundation when the load is transmitted to a strata at considerable depth below the ground surface. So you see, we can see this figure, these shallow foundations. We are studying about the preview of geotechnical field problems. So if you are not going to study the physical property of the soil and how much load is going to work on the soil, right? Without knowing the principle of soil mechanics, right? Without knowing the principle of soil mechanics, you are going to construct the shallow footing. In that case, the foundation may settle, or shear failure below the base of the footing may occur. Similarly, in case of deep foundation, if you are not going to carry out a study about the properties of the hard strata, the problem will arise. The problem will arise. You see, for foundation, it is always required to know the bearing capacity of the soil. That means the soil which is available below the base of the footing. We should know what is the bearing capacity of the soil below the base of the footing. Probable settlement of the foundation, depending upon the type of soil, we should also know how much settlement should be there. We should also know the effect of groundwater table, where at what depth groundwater table is there, right? So effect of water table on the bearing capacity of footing, we should also study. The effect of vibrations. Suppose you are going to construct the structure nearby the mines, right? So as you know, during the mining, vibration also occurs. So that point also we have to consider. So what I'm trying to say that without knowing these things, if you are going to construct the foundation, the geotechnical field problems will arise. See, the suitability of various types of foundation, like for example, a split foundation, which comes under the shallow foundation, foil foundation is the deep foundation, well foundation is also the deep foundation, depend upon the type of soil strata, magnitude of loads, and the groundwater condition. You see, these three important points are there. So suppose if you are going to construct the shallow foundation, in that case, the magnitude of load of this coming from the structure will be different. And in case of the pile foundation or deep foundation, the magnitude of loads will be different, right? So depending upon the soil strata, suppose this soft soil strata is there below the ground level. In that case, we have to think which type of foundation will be suitable. If these three conditions are there, see, we have to also consider the magnitude of loads of the structure, what type of strata are available below the ground surface, because some soil strata may be weak, some may be strong. So that study should also be carried out. Groundwater table conditions, whether at what level the groundwater table exists below the ground surface. So these points, these parameters should be studied. Otherwise, the field problems will arise. So similarly, we have to also have the knowledge about the shrinkage and swelling characteristics of soil beneath the foundation. Without carrying out the study of, without carrying out a study of soil, if you are going to construct the structure, the problem may occur. How? Suppose you do not know whether it is which type of soil is there at the site. Suppose it is a black cotton soil, which may swell or shrink depending upon the season. So these points should also be studied. The study of soil should be carried out. Otherwise, there is a chance of geotechnical field problems. Once you are going to construct the foundation, we are talking about the foundation. Without knowing these parameters, definitely the field problems here. The field problem means that the structure may collapse. There may be settlements, right? So the problem will arise. We shall see the next point, the retaining structure. This is also a civil engineering structures. So what it says that an earth retaining structure is required to keep the soil at different levels on either side. So soil engineering gives the theory of earth pressure on retaining structures. You can see, if you are not going to study the property of the soil, suppose you want to retain this soil, this side, and this is the retaining wall. So without knowing the properties of this soil, or we can say how much force is going to work on this retaining wall, without knowing the properties of the soil, without knowing the earth pressures, you are going to construct the retaining wall. It may collapse, right? So the soil engineering means as you know, and we have studied in the previous slide, the principal application of soil mechanics for solving the field problems. So if you are going to construct the retaining structure without knowing the properties of the soil, without knowing the forces, the retaining wall will collapse. That means we have to design the retaining wall depending upon the forces going to act on this structure. Similarly, you can see the seed pile. In the case of seed pile wall, if you want to retain this soil this side, and here the dredge level is there. So what should be the depth of the driven part of the seed pile wall, right? Depends upon the load or horizontal forces going to work on the sheet pile wall. So that means we have to know how much forces are going to work on the sheet pile wall. Accordingly, the sheet pile should be driven below the dredge level, right? That means what I'm trying to say here, the geotechnical field problems will arise for every civil engineering structure unless we shall not know how much forces, how much loads, how much pressures are going to work on the structure, civil engineering structures. So you can see the next point, stability of slopes. The components of weight of the soil in slope tends to move downward and causes instability of the soil. As you know, we have been constructing the embankments, right? For the highway, maybe for the laying of railway also. And you can see we can also construct the canal, right? So you can see the slopes are here. Here also the slopes are available in this excavated part. So if you are not going to study the shear strength properties of the soil, right? You have to also study about the factor of safety. You have to also decide, right, using the various softwares, what should be the slope angle. So all the properties, the geotechnical properties, we have to study, right, before construction of the embankments. Otherwise, the field problems will arise. So that means the stability of slopes depends upon the properties of the soil, the shear strength properties of the soil. It will remain stable only after knowing the shear strength parameters as well as the factor of safety. Here also, what should be the slope angle? If you are going to increase the slope angle and the height of embankment, you are going to increase, and slope angle also you are going to, suppose you are going to increase the slope, increase the slope angle. In that case, this part will become heavier and the slope failure will occur. That means we have to always study the geotechnical properties of the soil before construction of any civil engineering structures. And as I told you, the slope may be natural or man-made. These are the man-made slopes, and the natural, in the hilly areas, whatever the slopes are there, which are called as natural slopes. So as I told you, we have to know about the soil engineering. We have to carry out the study of soil engineering to protect the slopes. That means the soil engineering is nothing but the principal application of soil mechanics for solving the problems. We can see the next point. This is also a civil engineering structure, underground structure. Suppose you are going to construct the tunnel, or you are going to lay down the conduit. So what is going to happen? The design and construction of underground structures, such as tunnel, shafts, and the conduits, require evaluation of forces exerted by the soil on this structure. What does it mean? You can see the underlying part. If you are not going to study how much forces, because this side also all the soils are there, all the rocks may be there, and this is the opening, this is the tunnel. So if you do not know prior to construction of the tunnel, what will happen? The forces of these materials will work on this tunnel, and the tunnel may collapse. Similarly, if you are going to, suppose you are going to lay down the sewer line or the water supply pipeline below the ground surface. So how much forces on the pipes are going to work, right? That also we have to know. Otherwise, you have to maintain the thickness of the pipes, or we have to maintain the strength of the pipe depending upon the forces acting on the sewer lines or the water supply lines. Next, you can see the pavement design. Whenever we are going for the construction of the roads, we have to study the geotechnical properties or physical properties, which are also called engineering properties of the soil. So because the thickness of the pavements depends upon the strength of the subgrade materials. What I'm trying to say here, if you are not going to study the physical properties of the subgrade materials and directly you are going to construct the roads, so in that case, due to the traffic load, the soil may, the roads may collapse, the roads may damage. That means geotechnical field problems will arise. This is also a civil engineering structure, pavement design, construction of highways. So thickness of the pavements and in components. Component means the first, this is the subgrade materials. So we definitely we go for the, if the quality of soil is not good, we can change the soil, right? We have to compact it. Then the sub-base material, the base and surfacing is there. So what it says that the thickness of the pavement and its components parts, bitumen layer, base and sub-base depends on characteristics of subgrade soil, which should be determined before the design is made. That means being a geotechnical engineers, we have to study the properties of the soil, and then we have to design the thickness of the pavements. Without knowing the quality of soil, without knowing the properties of subgrade materials, if you are going to construct the roads, in that case, the geotechnical field problems will arise. We can see here, next civil engineering structure, the earth dam. As we know that the earth dams are the huge structure in which soil is used as construction materials. The earth dams are built for creating water reservoirs. So since the failure of the earth dam may cause widespread disaster, extreme care is taken in the design and construction. See, the earth dam has been constructed to store the water, which may be used for the hydroelectric projects or recreation purpose or for the water storage. So if you are going to construct the earth dam, you have to know the properties of the soil which is available below the base of the foundation of the earth dam. We have to also know the physical or geotechnical properties of the earth dam materials, because it is going to be constructed using the soil. So which type of soil is there, whether it is well graded or poorly graded, or what is the property of the foundation soil. So all the things should be studied. Then we should go for the designing, right? And then we can use the proper the core so that we can control the seepage, and the filter we can also use. So what I'm trying to say here, in both the cases, the materials, the properties, physical properties of this earth materials and the foundation materials should be studied. Otherwise, geotechnical field problems will arise. So always we have to have knowledge of soil engineering. Soil engineering means the physical properties of the soil engineering means the principle of soil mechanics, application of principle of soil mechanics for solving the practical problems. You can see the next point, the miscellaneous soil problems. What should be the miscellaneous soil problems? Soil heave, clay soil which swells when wet. So unless we shall not study about the soil property, how we can say that it is a swelling soil or having the soil has a shrinkage property? Soil subsidence, frost heave, shrinkage and swelling of the soil. So what it said that the soil provides an in-depth study of the such problems. So a thorough knowledge of soil mechanics is prerequisite to be successful foundation engineers. It is difficult to draw a distinguishing line between soil mechanics and foundation engineering. The latter starts where the former ends. What does it mean? It says that without going for the soil mechanics, without studying the physical properties or geotechnical or engineering properties of the soil, we should not go for construction of any civil engineering structures. Otherwise, the field problems will arise. So this is all about this topic today. Thank you very much.